As you've probably figured out, we're trying to draw a very strong connection between logs and exponents. And, exponents have these great properties that you guys know really, really well. And it should be no surprise that log is going to have similar properties. Let's do a quick review of these exponential properties so you know what I'm talking about. You guys had learned that if you are asked to multiply two things together with the same base, you're going to add those exponents. Like, for example, if you see a squared times a cubed, you know that that becomes a to the fifth. If you just think about the expanded form of these, that makes sense. But what I wanted to point out was when you're asked to do multiplication, you end up doing addition. And we've talked about how exponent properties kick things down a notch in the past if you've watched my other videos. We know that if we divide two things with the same base, we end up subtracting the exponents. So again, we see if we're asked to do division, we subtract exponents. That gets kicked down a notch. And we also know that a power to a power multiplies a power. So if we're given exponents, what do we do with the exponents? We actually multiply them. So logs have similar properties. However, logs are, in a way, an opposite of exponents. So they kind of have opposite properties. Here's what I mean. If I have log base a of m, and I add log base a of n, I'm being asked to add. What I'll actually end up doing is, if the bases are the same, multiplying those two things together and writing it as one single log expression. So when I was asked to add, I end up writing one log and multiplying. It kicks it up a notch. Likewise, if I had log base a of m, subtract log base a of n, so as long as these bases match, I would end up condensing it, one log expression, m over n. So subtraction will turn into division. And then finally, if I have a multiplier, if I have like m times log base a of n, that's a multiplier. This m is multiplying the log. I can condense that as log base a of n to the mth power. So when I'm being asked to multiply, I'll kick it up a notch. It'll become exponentiation. So these are the properties that are written on your notes. I might have used different letters, but you want to be aware of these. And you basically want to be aware that, addition will turn into multiplication, subtraction into division, and multiplication into exponents. So we'll do these problems over here in a second, so sit tight for the next video, and you'll see me referencing these videos, maybe I can just do it right now. Yeah, no, you'll see me referencing these properties as I do these problems over here. I will say, too, these are the kind of properties that, for me anyways, when I first learned them, it wasn't something that really made sense to me, other than through this connection that I understood already. It's something I kind of had to get used to, and then once I got a little more advanced and sophisticated, I could really explore why this would be the case. But for now, you were definitely in the acceptance stage. Know that this is kind of what has to happen.